Well, hello ladies and gentlemen, and welcome to the Test House webinar on Visual Studio 2012 version control. Here are some of the things I hope to be talking about in the upcoming webinar. I'm going to do a quick introduction to our company. Then I'll be talking in general terms about the TFS version control system. I'll be talking about workspaces, which are absolutely fundamental to the way that the TFS version control works. Then say something about check-in policies, which helps you with your quality control. Basically, how to check something in, check something out of the system. And following on from that, how the system deals with conflict resolution. That's if one person tries to check in a file which is on top of somebody else's changes. And then branching and merging, a useful technique, and I'll be going through a simple demonstration of that. And also then some new features with shelf sets, some things you can do in 2012. So some quick notes about Test House. We're headquartered in London with regional offices all over the world. We have full service centres in London, Madrid, Kenya, Dubai, and also some offices in the US. Sales offices in the United States and Saudi Arabia. We've undergone massive growth recently, and we offer a cost-effective and quality schedule for our testing services. There are several ways we can help you. We can provide people, either testing professionals on your site or remotely to help you with your testing efforts. We can help you with your projects, that's the strategy, all kinds of testing, automation, and also some training. And we are Microsoft Gold partners in Visual Studio and also other suppliers as well. So if for any testing needs you have, we have people who will be able to help you out. Here are some of the clients that we've worked with in the past. You see there's quite a few big names there. We do big and small testing projects. As mentioned before, we're a Gold partner. We are quality certified on ISO 9001. We have experience in a wide variety of markets. We have local knowledge and also globally people to help you with your resourcing, and we are independent consultancy, so we can help you with any technology you care to choose, and we're experts and we're highly flexible in the way we approach any project. So here are some of the things we offer in for our support for you. Test manager support. We can help you in V-model or waterfall, and also we're trying to get towards help people towards the agile testing and process. We can help you with your automation, your performance testing, and also a wide variety of training courses we provide in Visual Studio technology. So now we'll jump straight in and talk about the TFS version control system, how you can use it to your best advantage. Well, it's important to understand that version control is just a small part of the Visual Studio suite of tools and technologies. Quite a few companies, they only use Visual Studio just for the version control because it is quite a mature, useful system. But there's a whole host of other technologies will take any information which is automatically generated during the project lifecycle and help you control your projects. So it's a very good tool to use and deploy within your organization. So concentrating now on the code control system, it's what's known as a centralized code control system. That means we have a central repository of all the code that is under control, and then the users check in and check out the files that they're interested in. And the central repository is known as the truth. So every day it's recommended that you check your work in to update the central repository, because that is what's held as the latest version. So you check your files out and you hold them locally until you're ready to check them back in again. When they're checked in, then they're held in the central repository. So you do develop locally on your local hard drive or your local PC. You can get out the latest version of any file you're interested in using. Before you actually do any work, though, you have to set up what's called a workspace. And a workspace is essentially a mapping between your local environment, a PC or what have you, and the server where the files are stored. So you check those out, you make your changes, you test your changes, and then you can check the files back in again. Or you can make what's called a shelf set. So you don't have to check in your changes into the main repository, code repository. You can make your own little check-in space if you like, if you're not ready to check things in, but it is there and backed up and under code control, just not in the main branches of the code control. And you can also control builds from your local PC as well. So the interface to the code control system is in Visual Studio 2012 is through the Team Explorer window, which you can see a picture here on the screen. And this is really the entry point to a lot of functionality for Team Foundation Server from Visual Studio. But we'll be interested in, of course, in the code control area. But there's a lot of other functionality in there that you can get to grips with. I'll be running some demonstration videos during the course of this presentation to show you various aspects of the source control functionalities. And here is the Source Control Explorer window, which is where everything happens, where you check in, check out, and you can build your branches and do your merges. It really happens from this window, so you'll become very familiar with this window. And at the top there, you can see the workspace is shown there, the particular workspace I'm using at this time. But the first demonstration I'll show you is actually how to build a workspace. That's the first thing you have to do when working with code control. So we need a workspace, and there's 4 elements to a workspace. There's the version control path, which is where on the server can you find the files that I'm going to be interested in. Then every workspace has a user who owns it and a machine that it's hosted on, that it refers to, where the files will be coming out to, and a local path within that machine, which you can specify somewhere on your local drive. So it's a mapping between the server where the files are stored within version control and a folder where you want those files to appear. And that mapping is maintained for you. And so you don't, once the workspace is defined, you don't have to worry about that anymore. So here we have a screen where a simple workspace is going to be defined. And I'll point out some of the things that you can do within a workspace using this screen. You can see there, point 1, every workspace is built up of a series of source control folders and local folders. So on the source control folders on the left, that's where the system will find the files on the server. And on the right hand side, that's where they will be copied to when you do a checkout. Now, an active folder, the default behavior is that the system will check out all the files within that folder and also any subfolder also. So if you specify the root folder of a project in an active line, then the system will check out all of the files and all of the subfolders within that project. And it's important to try and keep your workspaces as focused as possible, so as not to get out any files that you're not interested in, because obviously you don't want to clutter up your local folders with any files that you're not going to be using. And so to that end, if you look at note number 2, you can see there is something called a cloaked folder. And what this allows you to do is that if there's a subfolder in the project that you know you're not interested in, so for example it's the responsibility of another developer and you know you're not going to be using those files, you can specify that folder and then set it to cloaked, and that means the system will not now retrieve any files from that folder. So you can discount any folders from the workspace. So that's what cloaking does. And you can see there's some other examples at the bottom, and they're all pretty much the same, except when you get to Note 5, you can see the /* there on the end of the source control folder. That overrides the default operation, and that means that the system will not check out any of the subfolders below that particular folder. So if you're only interested in the one folder and not the subfolders, then you can specify it in that way, and you'll only get that one folder effective in your workspace. So using those techniques, you can just concentrate on the files you're interested in and only have the files that you know that you're going to be using. You can also change the permissions to different workspaces. So you can have a private, a public, limited, or a public workspace. And working from right to left, if you have a public workspace, that means everybody can use it and everybody can check things in and out and do all the operations which you can do in a workspace. So you can produce a public workspace for everybody. You can have a limited workspace, which means only the owner can actually check things in. So people can read things out of it, but only the owner can actually check things in using that particular kind of workspace. Okay, and then you have a private workspace where everybody only has read access, and you have to be the owner to do any other kind of operation. So depending on what kind of use you have in your organization is what kind of permissions you would like to give them in their workspaces. Okay, when you define a workspace, you have some advanced options that you can choose, and this will be clear in a demonstration you'll see in a few minutes. You specify the owner and the computer that the workspace is going to be active on, as you saw in the previous slide. You can have a local or a server workspace, which means that the files are stored locally on your own machine. That's default. Or you can have what's called a server workspace, which means that the files you check out are stored somewhere on the server. And there could be various reasons for doing that, which I'll go over a bit later. You can also alter the time, which is on the timestamp, which is on the files that you check in. They can either be the current time, or they can have the time of the last check-in that was made. So they can be the time that you last did an update, or the time that you actually check the files in. It's up to you how you do that, and you can set the permissions as well on the workspace. So that's some advanced options that you have on the workspace available to you. Now the differences between a local and a server workspace, I mentioned that before. The local workspace stores its files on your local machine, and the server stores the files on a server somewhere. The reason you might want to do that is that if you have a very large number of files that you think you're going to be checking in and out constantly, and that's going to cause a lot of network traffic, then you may decide to make a server workspace so that you don't have to have lots of things going over the network all the time. Or if you work in a very secure kind of environment, and you don't want files to come out of the server and go out anywhere, even onto your employees' machines, then you may choose to have a server workspace set up for them so that the files stay in a very secure environment. That's a couple of reasons why you may choose to have a server as opposed to a local workspace. So, as I mentioned before, we have some demonstration videos for you, which I will play.
Right, now I'm going to show you how to create a workspace in Visual Studio. That's a mapping between the files on the server and the local copies of the files that actually work on. So if I go to the Source Control Explorer, I have a demonstration project which I've set up called Version. And I want to make a mapping between the files in this project and a local copy. As you can see, it's not mapped at the moment. You can see local path not mapped. So there's no mapping, so I can't actually check anything else at the moment from this project. Now I could just click that link and I could set up a mapping for this one folder. But that's not what I want to do. That's just an option you have. If you want to make a workspace proper, then you go up into this area, workspace, and the workspaces option. And you can make a new workspace using this screen. So I'll add a new workspace, and you have to give it a name. Control workspace. And you define the links down here. So on the left-hand side, you have the folder on the source control server where the files are. So I just hit the ellipse, and I can choose where on the folder the files are that I'm going to be interested in to check out for this workspace. So I can take the root of the project if I want to. You may not want to do that when you make ones for real, because you want to try and keep them as focused as possible with your workspaces so as not to check out anything that you don't need. And on the right hand side here, you define where on your local machine you actually want the files to be copied to when you check out, so you can work on them. So I have a folder here already set up where I want the files to go. And that will check out now all the files in the version directory and also any subfolders. That's the default behavior of a workspace. But if I know there's a folder that I don't want files to come from, to be checked out from, what I can do is I can define another line in the workspace. And let's say we have a properties folder here, and I'm not interested in the files from this folder. I can define that, specify that. On the right-hand side, the machine automatically fills in the destination local folder. But if I say it's going to be a cloaked mapping, that means the workspace will now not check out anything from the properties subfolder, from the version folder. So it's a way of making sure you don't check out any files that you're not interested in. With the Advanced tab, you have some more options on your workspace. So you can make it a local or a server. So you can make files go to the server or a local drive, as I've done. You can make it your timestamps be the current timestamp or the timestamp of the check-in that you've made. And you can also alter the permissions of the workspace, make it a private, public, limited or public workspace. And that changes the permissions. You can add a comment onto the workspace, and down the bottom there you can see the linkages that you've made. So I'm going to save the workspace as it is and close down that window. So now, as you can see, we have a workspace, and you can see that it's actually the local path has now been specified for this particular project. Now I can click that link and actually go to the place on my local drive where the files are going to have been copied to. But as you can see, it hasn't copied the subdirectory, subfolder that I cloaked. So it's only taken out the files that I'm interested in for this project. So that's how to set up a workspace in Code Control.
So that's workspaces, and that's the first thing you must do when you set up a new project or start working with a new project. Set up a workspace so the system knows where to check out the files to. Moving on now to check-in policies. This is an area of the Code Control system where you can help with the quality of your work. And there's various things you can do here to enforce things that must happen before anybody can check in their work. So you can specify that a build must be successful with the changed files before it can be checked in. There must be a comment included with the change set that you check in with all the files. You can actually customize the check-in policies that only applies to certain directories, certain files or folders. You can forbid certain names, patterns of names for the file names. You can specify that work items must be associated with your check-in. That's a useful one because it lets people know what work has been completed when you check in a file. And you can specify that only certain work items are eligible to be used with a check-in. That's what the work item query is for. And you can also have things like add notes. So a manager or a reviewer must include a note when you check in a piece of work. This is all to try and maintain quality. So I have a demonstration of.
When it comes to trying to control quality with your check-ins, there's certain things you can do. Before you start work, as well as setting up a workspace, you can set up what's called check-in policies to enforce people so that when they check things in, they have to have abided by certain rules to make sure that the quality is upheld. So you can see in this screen here, you can have checkout settings. It's default that you can have multiple checkouts. But what we're interested in really is the check-in policies behind this tab here that enforce certain restrictions on when people can check work in when they've been working. And I'll go through here one by one. You can make it so that a build must succeed before things can be checked in, so no one checks any bad code which is going to break a build. You can make sure that comments are included on a check-in so that people can understand why things have been checked in. If there's any code analysis that's been set up, you can enforce that that has taken place before a check-in occurs. Custom path. You can make these policies only affect certain files, and this is where you can define which path and which files you want to enforce your policies on, so that you can choose which files the policies are live. You can make forbidden names on the file so that certain patterns are not allowed. And a work item query and work items are kind of related. You have work items like bug reports and requirements. You can make sure that when people check their work in, they associate a work item with a check-in so that it's obvious what has been worked on for that check-in. And so you can go back and you can find out why a certain piece of work has been done and why a check-in has taken place. That's very good for, that helps the testers as well when they're trying to work out on a build what they should be testing. And work item policy, query policy, you can make it so that only certain work items can be associated with a check-in. So that maybe, for example, at the start of a project, only requirements can be associated with a check-in. So you can enforce that policy. Or you can make any kind of query that you want to be associated with a check-in. So some of these have to be configured further, but we'll do a comments policy. That's a quite simple one. This just reminds the users to make a comment when they check in. Check-in notes. Different people can make notes against check-in. So, for example, a reviewer. So this makes sure that someone is doing a code review against the code that's been checked in. So you can make it's a requirement that a reviewer puts in a note. You can add some more notes. So a manager. So you can make it mandatory that a manager also has to put in a note against it. And on the right-hand side, you have required. You can make a note required or optional. So a manager may or may not want to put in a note against a check-in for that particular policy. They're very useful for quality.
So check-in policies are very important to set up before people start to work to help maintain quality. They're very useful things. So now that you've got a workspace and you've set up your policies, it's time to do some actual work. You can add files and folders to the code control system. You can check things out. Anytime you check something in, it goes into a pending changes state, and you have to actually go in and expressly say you want your pending changes to take effect. That gives you a chance to back out if you want to. You can actually shelve something, so if you don't want to put something into the main area of code control, you can make a shelve keep it safe, but it's not in the main area. Check in when you've finished your work. Manage conflicts so that if people check the same file in, because people can check the same files out, if they try and check the same file in again, they're going to have conflicts. That can be managed, and you'll see how to do that a bit later. You can view history of files to see who did what and when to different files, if you need to know that. And you can also compare different versions of files within the code control system to see how they differ. So there's a lot of things you can do. And that's just, there are other things, but that's the main things you'll be wanting to do on a sort of regular basis. Before we go any further, I just want to make sure that I explain fully what is meant by a change set. It's quite an important concept within Visual Studio change control system. As well as the files that you're checking in, obviously, there's also a lot of other things that can be associated with a change set. Things like work items, that could be bugs or requirements that you're working on, or comments, people's notes, and of course the date and time, and all these different attributes of a change set are automatically recorded and stored in the system, so that it's very easy to understand exactly why something was checked in and what was going on and what work was being done just prior to the check-in. So that's what's meant by a change set. It's not just the files that are checked in, but also anything else that you want to associate with that particular check-in, just to aid traceability within the project. So I will now run a video which basically just talks about checking something in and out. So this is, we're going to show how to check something in and out quite simply now. So I'm in the project that I made before, and let's say I'm interested in this file class.cs. I can get the latest version. It's saying, do you want to have the latest version? So just to make sure that I'm up to date. I can check the file out to edit. So this is giving me a chance to confirm what files I'm interested in. This tick here means that it's checked out for me and I can edit it. So I can now double click it and open it, and I'll make a little change. Just add a comment, just to simulate someone doing a little bit of development on the file here. So I'll save it and close it. And now I want to check it back in again. So we can right click and check in the pending change back into the code control system. And on the right hand side you have an area for pending changes. So any change you make isn't checked in immediately. It is a pending change, and I have to say that I'm ready to check it in. I have the option to undo my changes if I want to, if I feel that I want to undo everything before checking it in. So that can be useful if you're not happy with what you've done so far. But if you remember, I did set up a policy which means that a comment is needed. So I can type in a comment there. I can override my policies if I want to, but I have to have a good reason. So if I override the warnings, I have to provide a reason why I want to override it, just for the record. But I will put in a comment here. First change on this file. Okay. Down here, it's got a list of the files which are included within this change set, just the one file on this occasion. And down at the bottom, I have the notes. And the reviewer note is required because that was set up in the checking policies. So I must get this file reviewed by somebody, and they must provide a comment before I can actually go and check in the file. There's also a space for a manager note, but that was not defined as mandatory. So a manager there can put a note in if he wants to, but it's not essential, not needed for this check-in. And here I can associate any work item that I want with the check-in. And that can be very useful to track work and understand why a check-in has taken place. So if you've made queries, work item queries, I can just select any query, and then all I have to do is drag and drop any work item that's returned by a query over into the correct space here in the pending changes screen, and that work item is now associated with the check-in within the check-in. So anyone can now see why the check-in took place, and you can make that mandatory if you want to within the policies. So once I'm happy with everything set up in the change set, I can go ahead and check the work in confirmation window. Just click that, OK. Okay, so the pending changes are now checked into the control system. And you can see there that the file has been checked in. It's not now waiting for me. So I can look at the history of a file now. Right click it and view the history. So you can see when it was added to the change control system. You can see when it was edited both times by me, the date as well. So all the information is there. And on the right hand side you can see what was associated with this check-in. I can open up the file and see the various versions at various stages of its life within the code control system. So everything is very traceable within this system. So that's how to check things in and out. It's sort of the bread and butter of the code control system, obviously. But with all this checking in and out, if people check out the same file, which by default people will be able to do, obviously you're going to get conflicts at some point. So one person checks out a file, and the other person checks it out as well. Another person makes a change and checks it in, and the other person makes a change to the same file, which is different to the first one obviously, and tries to check that in. You'll end up with a conflict. In other words, one person's changes will try and overwrite another person's changes. That's obviously not desirable. To overwrite somebody else's work. So there's a way that the system can automatically help you to manage these conflicts. It can automatically detect them for a start, and then there's a tool and there's a technique where it can help you actually manage that particular problem. And this is what I'm about to show you here. So what I've done is I've set up another user on my machine, and it's still to do with the class 1 file. I checked out a change with this other user, and I checked it back in again. And now I've checked out the same file as myself. So I've set up a conflict situation. So I'll demonstrate how the system can help a user to manage that particular problem. So if I make as you see, I've made an update 2 here. Okay, that's the conflict situation, the update 2. That's in addition to the change which the other user made. So if I right click and try and check in that change, remembering I still have my check-in policies in force, so I must agree to them. So the comment has to go in, conflict, and a reviewer must make a note. So he's reviewed it and it's fine. Nothing else I need to do. So I'll check that in and see what happens. And you can see the system has detected that there is in fact a conflict with this check-in. And it tells me exactly where the conflict lies, what change sets are in conflict. Now there's various options I have. I can keep the local version. That means I can check in my changes over the top of his. Probably won't make me very popular, but I could do that. Or I could take the version that's already there and forget my changes if I think my changes are important. Or you can use this merge tool where it shows me the lines which are in conflict, and you can see they're highlighted there my update to and the other user update are the lines which do not agree within the two versions of the file. So I have the lines highlighted for me, and I have some tick boxes on the left-hand side of each version. So by clicking those click boxes, I can decide in the bottom window of this screen is the resultant file, the file which will actually be checked in once the merge has taken place. So by clicking on the click boxes to the left of each of the files that are in conflict, I can decide which changes should go into the resultant file. You can see I've selected both. I can deselect them, and I can even influence the order in which the updates will appear. So if I want the left one to go first, I simply click the left one, and the right one comes afterwards. Or you can easily reverse the order if you want to by changing the order of the click. So that's both changes in the resultant file in the order which I specify. So once you're happy with the resultant file, you can accept the merge. Okay, and then that will change into, that means the check-in will then go into a pending state, as always. There's the pending change edit. So I've already done the comments and such, so I can go in and check in. No conflict this time, and the check-in is successful. For change set 36, which is my one. If I open up the file now, you can see that both updates have been saved away into code control. That's how to deal with a conflict resolution. Quite important that you want to be able to resolve your conflicts properly so that you don't end up deleting other people's work, wasting potentially days and days of their time. In a kind of a similar vein, what a lot of organizations do, they do something called branching within a code control system. This is useful if you have a code base, a project for a particular product in your organization, and you want to do parallel development on that product. For example, you want to work on different versions for different operating systems, or have different versions for with different functionality for different customers, as an example. And you want to do this quickly without too many clashes when people log in their work. One way around this is to have parallel branching, so that one team can work on one branch for one version of a product, and another team can work on the other branch. And they're so held separately, so they won't be in conflict with one another. But with branching comes the cost of sometime in the future you want to merge the two branches back together again to be the same main branch again. To continue the development with all of the different updates in the one place. This is quite simply accomplished with Visual Studio. You can also look at history of files and folders and who did what. It's important to keep your branching strategy quite simple as well, because an over complex branching strategy can quickly very easy to lose track of what's going on. So you want to keep it as simple as possible. So here's an example from TFS 2010 actually, but it looks very similar to 2012, and you can see those boxes like icons there and features. That signifies that a branch for feature team A and feature team B have been created, so that those two teams can work independently on the same files, but not interfere with each other when they do their check-ins. And then at a later date, those two branches can be merged back together again on one main line of development. So you must remember that unless that at some point in the future you plan to do a merge on these branches, there's no point in having a branch in the first place. So you will have to at some point merge the two, or possibly more than two branches back together again. So bear in mind, if the two branches become very divergent, very different, then you'll have quite a job on your hands when it comes to doing the merging. So bear that in mind when you're thinking about the branching. Also, it's very important before you start branching to know exactly what your strategy is going to be. It's not something you can do on an ad hoc basis. You really should sit down and think about how you want to do the branching before you start doing it, because you want to make sure that it's nice and organized and nice and defined when you do it. Otherwise, things can get a little bit messy and a little bit scary. So keep it simple. That's the basic message, really. And you can also manage branch permission separately. So a certain number of users, certain group of users can work on a branch, and certain can't. Certain users can't. You can even make a branch invisible to certain users, so they don't even have to be aware of its presence. The tools to do this branching is quite straightforward once you work out exactly what you want to do. So you can right-click a folder in source control, and you can then make a branch, and you can also manage the properties. You can visualize your branching strategy, as you can see here on the screen. You can see exactly how the branches are going to work. So it keeps it clear as to how the branches relate to one another. And you can also see, visualize and track the changes to files as you branch them and merge them. So here's a close-up of a hierarchy. You can see you've got a main branch, and version 1 and 2, and then testing branchings going again. So these branching strategies can get quite complicated if you let them. And when you do a merge at the end of the process, it's important to remember that you should always merge backwards from the leaves. That's the nodes towards the bottom of this graph, back towards the root. So you shouldn't, for example, merge feature A straight into feature B. That's called a basis merge, and that is something to be avoided because it can very quickly become chaotic if you start to do things like that. When you merge feature A and feature B back into the dev, okay, and then work backwards towards main when you do your merging. That way, everything can stay controlled. So that's the way the system is designed to work. So I have a demo for branching and merging. So I'll demonstrate how simple it can be on a simple example of branching and merging. I want to make a branch out of a certain folder, say the version folder. Okay, so simply all I have to do is I'll make a new folder called main. Okay, and I'll have to add that into the code control system. I have relaxed the policies for check-in so that I don't have to provide any comments and such, just to speed things up, but it's something you would want to keep obviously in real life. So I'll add a file to this folder that I'm branching. So this is going to undergo some parallel development, but in such a way that people don't get in each other's way. I have a file already set up that I want to try and do some development on, so I'll check that into the system as well. If we look in, it simply got main on it to signify that this is sitting in the main branch at the moment. Okay, so I have a new folder and a file that I want to develop. I decide that I want to do some parallel development on it, so I'll make a branch out of this folder. To do that, I can simply right-click it and branching and merging branch. And I can name this new branch. Okay, the source is main. I can change that, but that's what it is. So now you see I have a branch main and main branch 1. So it's made some branches for me, and I've checked in what I need to check in to make those branches active. Okay, I'll make another branch off the main again. I'll call it branch 2 this time, to keep it simple for the demonstration. More meaningful names would be called for, of course, in real life, but I'm going to keep it simple just to show you the way it's done. So I'll get the latest version for these branches just to make sure that I'm completely up to date before I start the development. It's always a good idea. 2 branches for parallel development from the main branch. Now I can view the hierarchy in this graph. So it's quite simple, main and 2 parallel branches off the main. So I can actually look to see that my design is as I think it should be before I start to do anything at all. So look at that graph first before we do anything. So now I can actually start doing some development on these branches. So I'll go into branch 1, and the branch 1 team decides they are going to do some development on this particular file. So just add something in there, save it, and check it in. And at the same time, the team that do the branch 2, they want to do some development on the same file. So branch 2 on this branch, and check that in as well. Right, so that's our parallel development. Quite simple. 2 branches, parallel development. So the time has come to do some merging. So if you remember, I did say that you have to merge back towards the root of this structure. So I can't merge branch 1 into branch 2. I have to merge branch 1 into main. To do that, you right-click the branch that you want to merge from, branch converging, merge. And it just walks me through it really. So it's saying you want to merge from branch 1 back into main because that's where it came from originally. Okay, yep. Latest version, yes. And finish, and it does it. So the first time you do it, it's not a problem because it's just like an ordinary check-in really, because you're just updating the check-in which was updating the file which was sitting in main with one update. So there's no problem. So you can see here we have the update from branch 1 in the main file. Simple enough. No complications there. So let's do the same thing with branch 2. Have to merge from branch 2. And the same question. It knows I want to go back into main because that's where branch 2 came from originally. So that's how it should be done. So that's what it prompts me with. So I'll check that in. And there's a conflict because the different development obviously results in different files. So when you're trying to merge them back into the main branch, you will get conflicts. That's the nature of parallel development. So you have the same kind of options. I can take this version from this branch and overwrite the version which is in the main branch, or I can discard the changes which are in this particular branch and just keep the one which is in the main branch. But as before, this is probably what you'll need to do. You go into the same conflict resolution tool as we saw before, exactly the same idea. I can decide which of the changes I want to include in the resultant file by clicking the boxes. You can see down here that it's building up. Branch 1, the 2 changes from the different branches. And as before, remember you can change the order of the changes that you want to be in the resultant file as well. Okay, so this probably takes some collaboration exactly how you do this, but this is the steps you have to go through. So once that has been done, okay, I can check in that particular merge which has been successfully resolved. If I look in the main branch now, you can see that the file now contains the updates from both branches. So that's a successful merge on those two branches. Now it could be that you have many branches you want to merge, so this could be quite a long process depending on how many branches you have. But that's how the system works. Now if I go back in here, I can view the history of a file through the branches. So here's the history of this particular file, and you can see there's an edit history, which you can view, and you can track the change sets through the branches. So you can see what happened as you branched and merged. So if I just highlight all the branches that are concerned, you can see that the change originated in main branch 1 in change set 97 when it was checked in, and was merged back into main under change set 99. So, and then of course when you do the merge or you do the check-in, all the things that are associated with that in the change set are available for you to look at. So everything is traceable in the history. A lot of information there. So if you're unfortunate enough that something should go wrong, you can look back in the history and you can see exactly what happened, and you can see when and why it went wrong. So that's merging and branching, quite simple, at least in its simplest form, but it can get complex if you have a setup which calls for more and more branches, but try and keep it as simple as you can and you shouldn't have many problems. I'll show you now some things you can do with shelf sets. So in my work here over on the right hand, over in the Team Explorer, you can do several things. You can see what tasks you have in progress. So you can set up a query which shows you which work items you're working on at this particular time. If you get interrupted by a higher priority piece of work than you're working on at the moment, you can suspend whatever you're working on at the present time, and the system will change that into a shelf set and go and put it on the code control system, and then you can go and do the work you've been asked to do. At a later date, you can open up that shelf set and everything will appear on your screen exactly as it was when you left, even down to the level of if you have a debugger active at that time and you have some breakpoints active in your debugger, it will even remember the position of the breakpoints. So when you come back and resume your work, you will resume it exactly in the same state as it was when you left it. So everything's saved for you. It saves a lot of time trying to get back into whatever you were doing. Another good feature is that you can make a shelf set and submit it for a code review. So you can ask your fellow developers for their comments on any code which you include in a shelf set. So you make a shelf set, they can go and pick it up, look at the contents and do a code review on that shelf set. There's a procedure for doing that. And also feedback requests from stakeholders and users. So, same applies. You can ask for regular feedback from the users, which is always very good to make sure that you're on the right track as far as functionality is concerned. So when you suspend your work, it parks all you have, including the breakpoints, as I say. Any windows that you have open will also be open when you resume. Any state of work items will be there ready for you when you resume your work, so you can get back into what you're doing very quickly. So we have one more video which will talk about how you can work with shelf sets. So let's say that I want to make a shelf set with some of the work that I've been doing up to this point. So here we have the ABC file, and I'll do a little bit more work with it. So I'll save that away, and I've changed it now, so it's ready to be checked in. I go to my pending changes screen. Now, instead of checking in, what I can do, I can create a shelf set for that file. So it doesn't go back into the main area of the code control system, but it's still safe in there. So it's a bit of work for myself, which I can go back to later if I want to, or I can share it with other developers. I can associate a comment with a shelf set, and like anything else, I can associate a work item with it. So here is my version control task, which I can just simply drag across, and I can associate a work item with a check-in that goes into that shelf set. So you can do all the same things you have before. So I can go ahead and shelve it now, and then in the action I can find the shelf set which I have made previously, so I can open them later again. So there's a shelf set 2, and it has all the details of that particular shelf set. I can request a review of the contents of the shelf set, so I can go and send a message to some other people in my team to say, please write a review on the contents of the shelf set, and they can write comments back to me, and then I can open up the shelf set again and look at what comments they've made. So that's how to do how to request a review. But I can also suspend work. So in the my work area, I can simply suspend the work that I'm doing right now. So I can look at the works I've suspended. I can associate a bit of work with the suspension, which is always good to do to remind me of what I was working on at that particular time. I can associate as many as I want, not restricted to just one item. Okay, so I'll suspend the work. I can put a useful comment against there to remind myself or anybody else who wants to pick up this suspension. If I go on holiday or something, someone else can pick it up. So I can make a comment there, so I can suspend the work, and everything now is put into a shelf set. Okay, and there's a list of all the previous ones that I've made. So I can make, if I want to make a breakpoint, I can, and go back to it at a later date. So I can highlight the one I'm interested in and resume it, and then it loads it all back up again. And there I am. My position is exactly as it was when I made the suspension. So it's a good way to deal with interruptions of high priority work. That's just some of the things you can do with shelf sets. Okay, so that concludes the presentation, the webinar on code control for Visual Studio 2012. Just a reminder that Testhouse does offer a wide variety of training on Microsoft products, and also on the theory of the testing as well. So if you want to know about any of these topics, how to use these Microsoft products, we can provide testing training on that, either on-site or off-site, as you see fit. There's also something called DTDPS, which I'd like to draw your attention to. That is a scheme that's paid for by Microsoft. So if you buy Microsoft products with your license, you may have free consultancy days. And as a gold partner with Microsoft, we can come in and we can give you free consultancy paid for by Microsoft on your products. So that's something we're worth considering. If you go to our website there, you can find out all about it, or drop us a line on the email addresses you see there, and we can find out about these things for you if you have any consultancy days available to you, or if you're interested in anything else that we can do for you. So thank you very much. I hope you found this interesting and informative. Thank you.